Okay, let's continue with the rhombus. All right, we know it's a parallelogram. We know it's a parallelogram. And we know it kind of looks like a square that's kind of leaning, right? It's kind of leaned over square. All the sides are congruent. We just talked about that. Or it looks like a diamond. Could look like a diamond like this if you kind of turn it this way. But again, still all sides are congruent. Ooh, that one's kind of ugly. Again, all sides are congruent. We just talked about that in the first video. But the angles can't be 90, right? Because if it was 90, then it'd be a square. But what is going to be true about the angles? Well, we said, like for parallelograms, if you have a rhombus, we'll talk about the angles now. What is true about the angles? Well, because it's still a parallelogram, if this one's like, let's see, that looks like 70 degrees, then we should be able to find these other ones, angle 1, 2, and 3, right? If that's 70 degrees, it is still true that what? Well, if this one is 70, then what is true? Then these opposite angles are still what? Congruent. The opposite angles are congruent. That means this one's also 70. Okay. And then how do we find these other ones? I mean, I need to know something, right? Remember I talked about it earlier in the first video. These add up to what? These same side, these angles that are on the same side add up to what? They add up to 180. So what would this need to be? 110, right? 110, and if this is 110, this one's also 110. Okay. So now the problems you're going to see, well, let me continue. So that's still going to be true, but what's something else that's specially true about a rhombus? Well, here it is. For a rhombus, let me draw another one over here. Does that look like a square kind of leaning? Yeah. Okay. Now what's going to happen is now when we introduce a diagonal. Now I'm just going to show you one right now. I know there's another one going this way. They're not the same size. I can see this one's longer and this one would be shorter. Okay. So the diagonals of a rhombus, only of a rhombus, diagonals bisect the angles. Bisect means to what? To cut and divide equally in half, right? Equally in half, to bisect it. So let's say if this is 100, right? I still got the whole thing. If this one's 100, well, this one's 100. Okay, right? Remember that? Kind of picture it without the diagonal. If that's 100 and that's 100. Then how much would this one have to be, right? If you picture it without that diagonal, if this is if this one's 100, this one's 100, right? Then this one would have to be what? This one would have to be 80, right? Remember, because they add up to 180. We just talked about it over here. This one has to be 80 and this one has to be 80. But look, it just got bisected. This diagonal bisected it. So what do you think that means? If it's 80, that 80, this thing that measures 80 right here got cut into what? 40 and 40. You see, so this is 100. These two add up to 80, or this whole big angle is 80, but now this would have to be what? 40, 40, and this one's also 80, right? So it's And what you're actually going to see is that there's what? Notice that this top triangle, this, you see how there's two triangles now? This top triangle has 40, 40, and 100, and so does this one, look, 40, 40, and 100. It's almost like I can fold it over. It's almost like I can fold it over, and they're congruent triangles. You see? They'll match. This triangle will look like this triangle over here. Yeah? Okay, now let's start it the other way. Let's kind of look at it the other way. All right. Here's another example. What if I have a rhombus? Well, let me go this way now because I've been drawing it the other way a lot. All right, it looks like a square because all the sides are congruent, but it's kind of leaning over so the angles are not 90. What if this is... Now, knowing this, that these will be the same and these will be the same, what if you start with this? What if you start with the diagonal already here? So this one's cutting this angle here. But what if they give you a problem and instead of giving you this angle here, what if they give you this little small one here and I tell you this one's 60? And you're supposed to find like all the other ones, right? Let's say you got this and they're asking you to find all the other ones. So they'll probably put like 1, 2, 3, 4, 5. Like, how are you going to find that? Okay. So remember, look at how this is right here. If this one was 40, then this other one's 40, and if these two are the same, then these two on these other sides are going to be the same. So we're just kind of working backwards now. So if that's true, let me draw this one again. If this is the scenario, and I have this rhombus like this, then this is going to be true. If this one's 60, then guess what? This is the diagonal. It cut this one in half. So if this is 60, this one has to be 60. Yeah? And if these two are 60, guess what? These two are 60 also. Does that make sense like we did it over here? So now what do I have? Well, I know that these together is what? These together right here is 120. These together are 120. And if this big angle is 120, remember these have to add up to 180. Or you can just look at half of it and say, hey, I have a triangle here. The bad thing is I'm just realizing is all the answers are going to be 60. That's why I'm kind of pausing. Yeah, hold on. So I can add these, and I know this is 120, and these two have to add up to 180. This is the reason I paused, because I know this one's going to be 62. Right? You can always look at just half of it and say 60, 60, that's 120 plus another 60, that's 180. And then once I figure this one out, then these two are the same. I got to do another one. I shouldn't have picked 60, because now everything's 60, and it kind of looks weird. All right, so let me do another one similar to this.